Hi, welcome to the Olympiad Geometry Club. Let's continue our study. Before we start, if you think this video is helpful, please click the like button, comment, share, and subscribe to the channel. So today we're going to talk about the XMO problems. It's actually from the IMO long lists, problem 15 and problem 36. So let's start. Given 4 points A, B, C, D on a circle such that AB is a diameter and CD is not a diameter, show that the line joining the point of intersection of the tangents to the circle at points C and D with the point of intersection of the line AC and BD is perpendicular to the line AB. Okay, that's the first problem, and let's draw the figure first. So the problem is saying that in the ABCD are cyclic, and we already know that AB is a diameter, right? AB is a diameter, and we can find the point CD that are not diameter. Then we want to find the tangent lines on the point D and point C. Right, roughly see this one. For this one. Okay, roughly see this line. Let's call this point as P. So we want to prove that this point connect with this point. Let's call this point as M, right? The PM, right? So it's asking for, show that the line joining the point of intersection of the tangents to the circle at points C and D, that's the point P, with the point of intersection of the line AC and BD, that's the point M, right? So this line is perpendicular to the line AB. So we want to prove that PM is perpendicular to AB. Okay, so actually I think this problem I solved it before, but I have a bad memory, so I don't remember the method I used previously. I think I'm using a new method here. Let's see. So we want to prove that PM is perpendicular to AB. I think the easiest way to solve this problem is to solve it separately. I say separately, I mean that let's just draw the figure again to make it easier. So the idea is that we want to prove that PM is perpendicular to AB. But what we can do is that we find the perpendicular line first. And this perpendicular line would intersect with AC on a point, and intersect with BD on another point. And we just need to prove that these 2 points actually are 1 point, right? So in that case, we don't need to draw the AC and BD at the same time, which means we have AB here, we have CD here, and we can draw the tangent line. Let's call this point as O. So we draw 2 tangent lines here. This is point P. And we can directly find the PF is perpendicular to AB. Right, we can do that. And then we connect AD, we connect CD, we connect CB. and we connect AC only. So the PF intersects with AC on a point. Let's call it M. Right? Now let's look at the angles in this figure. We know that angle MAF, this angle, equals to angle, let's call this line as Q and R, okay? So the angle MAF equals to angle QCB. Right? And we already know that angle QCB or angle MAF plus angle AMF equals to 90 degrees, and angle QCB plus angle OCB equals to 90 degrees, right? Which means angle AMF equals to angle OCB, right? So this angle, the angle AMF equals to angle OCB, this one. And we know that OC equals to OB, so it equals to this one. And we also know angle AMF equals to angle PMC, so it equals to this one, right? And because PC is a tangent line of the circle O, so we know that angle CBO or angle OBC equals to angle PCA, right? Angle PCA, this angle, equals to angle CBA, right? That's CBO. So we know, which means we know that angle PMC equals to angle PCM, which means PC equals to PM, right? That means in this figure, once we draw the perpendicular line from P to AB and we connect AC, we find the intersection point, we call it M, and we just proved that PM equals to PC. Then the things, this problem becomes very easy, right? We just need to do this again. So we have AB here, we have C here, D here. This is P, this is F. So we just do it again, so that we connect to the DB this time, and we call the intersection point as N. Then we connect AD, DC, and CB, right? Similarly, we know that the angle, again, here is Q, this is R, so the angle DBA equals to angle RDA, right? So this angle equals to this one. Then we know that because the angle DBA plus angle FMB equals to 90 degrees, and this angle, the angle RDA plus angle ADO equals to 90 degrees. So we know that angle ADO equals to angle FMB, right? And angle FMB equals to angle PND, right? And we know that this angle, let's see, this angle, right? This angle equals to angle PDN, right? The angle DAB equals to angle ODA equals to angle PDB, which means we get angle PDB, that is angle PDN. PDN equals to angle PND, which means PD equals to PN. Right. And comparing these two figures, we already know that PD equals to PC, which means PN equals to PM. And we know that N and M are on the perpendicular line from P to the AB, which means N and M are the same point, right? So that is saying BD intersect PF on a point, and AC intersect with PF on another point, and they are the same point, which means AC and DB intersect on this point, right? Which means the intersection point of AC and BD with point P is perpendicular to line AB. So we prove this problem. Okay, let's see the next one. Let ABCD be a quadrilateral inscribed in a circle. So ABCD is a cyclic quadrilateral. Show that the centroids of triangle ABCCDA, BCD, DAB lie on the circle. Okay. We have this A, B, C, D here, right? And we want to find the centroid of triangle. We want to find the centroid of the triangle ABC and CDA, which is ABC here, CDA here, and BCD and DAB. Okay, so triangle ABC, triangle CDA, triangle BCD, triangle DAB. We want to find the centroid of these triangles, and we want to prove that the centroid of these triangles are cyclic. So to prove this problem, let's just think about how to find the centroid in the easiest way, right? So I find the midpoint of these segments, and then we know that if I connect D, E, F, G, H, right? If I connect AE and CH, then I find the centroid of triangle ABC. Let's call it I, right? And if I connect CG and AF, I find the centroid of the triangle ADC. Let's call it J, right? And for the triangle BCD, we can connect D here, connect BF here, and we find the intersection point. We call it K. And for the triangle ABD, we can connect BD here, connect BG here, connect HD here, and find it, call it L. So now we want to prove that LI, K, J. Okay, we want to prove L, I, K, J are cyclic, right? So let me zoom in. So just think about the ways that we can prove 4 points are cyclic. We might think that we need to calculate the angle LIK plus angle LJK. If the summation equals to 180 degree, then it's a cyclic quadrilateral. But as you can see in this problem, definitely we cannot go that path because we don't know any information of these angles, right? But if you look at this problem carefully, you can see that we're looking at the centroids. And we know that centroids has a very specific property that because I is the centroid of triangle ABC, so AI to IE equals 2, 2 to 1. And CI to IH equals 2, 2 to 1. CG to JG equals 2, 2 to 1. And AJ to JF equals 2, 2 to 1. So based on all of these ratios, we should get some useful information here. Right, we should get some useful information. Let's think about that. Because K is a centroid of triangle BCD, so we know that DK to KE equals 2, 2 to 1. And we know that I is a centroid of triangle ABC, so AI to IE equals 2, 2 to 1, which means IK is in parallel with AD, right? Similarly, for here, we know that GL to LB, that is 1 to 2, and GJ to JC, that is 1 to 2, which means LJ is in parallel with BC. And HL to LD equals to 1 to 2. HI to IC equals to 1 to 2, which means LI is in parallel with DC. CJ to JG equals 2. Yeah, should be from here. AJ to JF equals 2, 2 to 1. And BK to KF equals 2, 2 to 1, which means KJ is in parallel with AB. Right. So you can see that the quadrilateral IKJL is similar to the quadrilateral ABCD, right? Because all of the reference sides are in parallel. So we know that IKJL is similar to ABCD. And we know ABCD is cyclic. That means it's a cyclic quadrilateral. That means IKJL is a cyclic quadrilateral. And we're done here. Okay, so in this video, I show the two problems of the very old IMO candidates problem. I don't think the second one is hard enough, and I think the first one currently is only the level of state level computation problem. It cannot be the IMO. problem. Anyway, I hope you like this video. See you in next one. Thank you.